Welcome to EDU World Space.
So we're given some information on this question that they must have sampled 100 people, and they found that 29% of these people, and these are women who were over 55, and found that 29% were widows. So they must have sampled people who were over 55, and that was just a sample. That's a p-hat. And so we want to know how big, and we're going to assume that that sample is probably pretty close to what P is, but we don't know what P is. And we want to find how large of a sample size. So what size N should we have so that we have a 90% confidence or a 90% confidence interval that would have the margin of error be 0.05 or 5%. So basically we want to have a p-hat. We want to have a p-hat plus or minus, and we want this margin of error of the z-star value times the square root of p-hat, 1 minus the p-hat over n. We want this component to be 0.05. So we know we want 90%. We look up that value and we get 1.645. Now, since we've gotten an estimate that this is pretty near to be 30%, we're going to use that 29% that they had suggested. And again, it might be off, but for our calculations, we'll be pretty close. So 1 minus the 0.29 is going to give us that 0.71. And we don't know n, but we want that to equal 0.05. So one thing we can do here is think of kind of splitting this square root up into the square root of the top and the square root of the bottom. I like to do it that way. And then I'm going to multiply both sides by the square root of n. And then I'm going to divide both sides by 0.05. So I would have 1.645 over 0.05. And then that would be times the square root of 0.29 times 0.71. And again, we're just going to put all this stuff in our calculator at some point. So now I'm going to go back and I'm going to square both sides. So we'll square this left side and we'll square the right side. And in doing so, we would end up with, and again, I'll put it all in my calculator at one point. We get that value squared over this value squared. And then this square will cancel out that square root. And this will just be 0.29 times 0.71. And when we hit that on our calculator, I did that a little bit ago, and I got 222 and it comes out to be 87. Now, regardless of what this decimal is, you want to round up. Therefore, we would need a sample size that's at least 223 in order to have a margin of error for our confidence interval be 0.05. Now, the next question says, well, what would we do if we didn't have an idea? If we didn't have an idea what the percent was for widows, and we didn't know, is it going to be, close to 50%? Is it going to be like 2%? Is it going to be close to 98%? If we don't have an indication of what it is, our safe number to use is 0.5. That's generally speaking what you use if you have no idea. So I would go back and use 0.5 here and 0.5 here, which means in our calculation, this value would be 0.5, this value would be 0.5, and let's just go down to our final answer. For this calculation, we would end up having n is equal to 1.645 squared, and we'd have 0.05 squared, and then we would have 0.5 and another 0.5. And why don't I go in, and I have not done that calculation yet, but let's quick hit it. 1.645, we're going to have that squared, divided by 0.05, have that squared, times 0.5, and I'm just going to hit it squared. And now when I do that calculation, I get 270.6. And again, regardless of that decimal, we want to round up. So we would need a sample size of 271. That's the maximum sample size you would need in order to have the confidence interval have a 5% margin of error. So that completes that question.